Ooh. Well, I guess I know what I'm working on today. Hello and welcome to Mellow Labs, where I make solutions to problems Reddit likes to call white people problems. On today's episode, I'm tackling the thing ADHD people struggle with the most. The song at the back of our heads that never goes away. Today it's Firework by Katy Perry. Help. I'm just kidding. There's no solution to that. What I'm actually tackling is taking medication. Because we constantly forget to. I've been looking for some kind of pill dispenser for a while now, and looking online, there are solutions that make me feel like a pensioner, or there are solutions that cost 3 times my rent. And you have to fill them individually, pill by pill. So we have our criteria. We want it to be cheap, we want it to be easy to use. I've already forgotten the other one because, like I said earlier, ADHD. I want it to be smart. I want it to annoy me until I take the pills. Cheap, easy to use, smart, annoying. That should be easy enough. I started off by doing some tests. Originally, I wanted the pill dispenser to not have any electrical components, but I'm not smart enough for that. So test number 1 and 2 were a failure. If at any point you don't see me looking into the camera, you see me looking to the side, I'm probably looking at the kettle. Which just makes me want tea. I think I found why I drink so much tea. For test number 3, I designed a container, partially inspired by chewing gum dispensing machines, that will rotate, collect a pill, and throw it out. And that worked, kind of. There was 2 problems with this design. One of which was the angle at which it was placed at. The other one was the thickness of the shield, which is what I call the thing that holds the pill. Those 2 problems often made it pick up more than 1 pill at a time, which I consider a problem because you don't want to take more than the required dose. Then I moved on to design number 4, which was basically the same as design number 3, but the shield was a little bit thinner and the angle was a little bit steeper. And again, that kind of worked, but we still had the same kinds of problems where it would pick up too many pills. At first, I thought I could solve the problem by simply adding a little border just before the pills exit that would prevent the pills from being one on top of the other, but also sideways in the container. But all that did was make a catapult. And I don't think slingshotting drugs into people's mouth is the way I want to go. So then I experimented. My mouth is so dry. So then I experimented with the design of the shield. I found out that it's better to design the shield to the pill instead of just having a generic one for all of them. So moving on to design 4.5, I knew that the angle had to be adjustable. I knew that I'm going to have to be able to swap the shields depending on what pill is in there. And I added another thing to my original criteria. I wanted it to be expandable in some kind of way, because I didn't want to have individual little dispensers for all the kinds of medication you need. Something that would consolidate it into one would be great. So why did I call it design 4.5? Because it was so bad and so just fever dream of a design that I didn't make it. I didn't even bother printing a single part of it. So let's move straight on to number 5. Number 5 incorporated everything I needed. Adjustability, expansion, smartness, ease of use, changeable shields, and here it is today. If that magic trick worked, I'm impressed. As you can see, it has more than 1 pill container. There are 3 in this one. The angles are adjustable. The shields you can take out and you can put them back in. They're great, and it's ready to use. So these 2 improvements, the exchangeable shields and the pivoting design, help it to only pick up a pill at a time. But we do occasionally still have the problem of it not picking up any pill at all. So to combat this, I need to know whether a pill has been dispensed. And if not, try again. The way I'm doing that is by this ingenious little vibration sensor. If I tap it, you'll notice that the LED goes off. So I'll just take a pill from the top here and I drop it down in. And that triggers the vibration sensor, which tells it a pill has been dispensed. Perfect. So let's move to the rest of the electronics. Here we have the Raspberry Pi Pico and a D1 Mini. The D1 Mini is primarily there just to tell the Pico to dispense pills. This was the easiest way for me to do it. I'm not smart. Now originally I did want this all to run off of the D1 Mini. The only thing that stopped me is the Arduino servo library didn't let me change the frequency of the servos, and the Pico did. So the Pico runs the sensor and the servos. Also, I'm much more fluent in Python than I am in C. I just don't understand how people do C. There's so many colons. So many colons. Now I know by default the servos are supposed to run at 50 Hertz, but I run them at 40 because it gives me a wider range of motion. I don't understand why, because my brain's not big enough. But driving the servo at 50 Hertz only gives me 180 degrees of movement. Driving the servo at 40 Hertz gives me like 220. It gives me the full motion of the servo, and having that extra movement lets me be a lot more accurate with the pill dispensing. I need tea. I haven't made the kettle smart yet. Put that on the list. So that's why I'm using both of these. He is for Wi-Fi, he is for everything else. So in very basic terms, he gets a signal, he tells him to move the motor. The motor moves, eventually it dispenses a pill, which tells this guy that a pill has been dispensed, which tells this guy that a pill has been dispensed, which then makes this guy move a different motor. And the process repeats until it dispenses one of each. So there it is. There's my pill dispenser. It has everything I needed to have. It is smart. It is cheap. It is expandable. It is easy to use. All you have to do is just put your pills in here and boom, there it is. After properly calibrating the pill dispenser, I was able to get it to properly dispense pills 10 out of 10 times. It did take a lot of trial and error, but it's definitely possible. But I wasn't satisfied with this being the final design. There are aspects of this design that I really don't like. For example, the geometry. This, because I adapted like 2 different versions of this, the geometry is kind of screwed up here. These walls are way too thick. These walls are way too thick. As you can see, the design of these changed like a quarter of the way because they were hitting each other. So I redesigned those. I don't quite like how this sits. This bit I had to add separately because I didn't think of adding a cup holder. I ran out of filament halfway through, so now it's half blue. So yeah, there are things to be improved. So let's move on to version 6. So here's version 6. These are all of the 3D printed parts you would need to build your own. So let's build it together. We're going to need some zip ties. So we're starting with the base because it's the base. If you only have one pill you want to dispense, this is all you need. And later on, if your doctor says you're still not doing very well, let's add some antidepressants into that mix, you can add another one. And then you decide, hey, I want a multivitamin in my mix every day. You can add another one. And you can just keep adding these. I don't know what the theoretical limit of this is, but you can just keep adding them. These are held together by zip ties. Tie 1, zip tie 2, zip tie 3. This goes on top. Zip tie goes through here. Zip tie goes through here. And then you can just cut off the ends of the zip ties. Now around the back you'll notice that we also have a recess for the vibration sensor. This gets the sensor really close to this inside bit here, where the pills hit when they fall down, which gives it the best chance of detecting when a pill has dropped. So let's add another level to this. Exactly the same process. Keep in mind, these do have an orientation. It's not very obvious, but on this side, there is a hole for the servo cable to come through, and you want to keep those all on one side. Yeet. My cleaner will get those later. I am my own cleaner. I hate myself. Great. Now that the base is done, we can move on to the containers. For this, we're going to need the 3 containers our 3 shields, 3 servos, these little connectors for the servo, which I've just chopped down so that it's just the middle bit that connects to the servo. You're also going to need 6 of these 12mm M3 plus the little nut screws, along with these M3 6mm ones for the servos. So we're going to start off by taking our shield, taking our little servo connector, putting a dab of glue in the middle of the shield. You can do this by hand, but I prefer to use some pliers. Just place the connector in the middle. And I'm just going to do this to the rest of the shields. There is a little circle in the design to let you know where to place the connector. So now, whilst those are drying, we're going to connect the servos to these 3 containers. I did also plan for there to be a little bit of room so that you can get the servo perfectly in the center of the hole. And there we go, that's all nice and attached. Now let's set this aside and do the other 2. So I was hoping for the CA glue to be dry yet, but it isn't. So let's move on to the vibration sensor. Now for this, all you're going to need is the little vibration sensor and a little Phillips screw that just goes in there, and then you can easily screw that in here. Cool, now that vibration sensor is firmly in there, and you can test whether it works later. Right, now we can take our containers and we can put them into the holders. So the cable goes through the hole here. Then through the holes on the side we can pass through a screw and align where that goes and put a nut on the other side. This bit is a little bit fiddly. If you'd like, you can use longer screws, it makes it a little bit easier. If you'd like, you can also add some washers either side of the screws. Personally, I don't think it's necessary because as soon as I've aligned these to be at the right tilt, I'm screwing them firmly so that they don't move. That's one. Let's do the other 2. One of the things that actually changed going from version 5 to version 6 is because I was able to get the walls to be thinner, I was able to make the drums 6% bigger so they can hold a little bit more. There we go, that's all of the containers in. Now we can go to the electronics. Now I actually expect this to change in the near future, hopefully just to use the D1 Mini instead of the Pico, but for now all I've done is just put them on a PCB board and soldered in the connections. And this doesn't really have a permanent place, so I just kind of blue tack it onto the back. Like I said, I expect this to change. So get your blue tack and just stick it on the back. And now we connect our cable. My cables are obviously going to be different colors than yours, so I expect you to know how to connect it. And then all the servos plug in here. You can put them in order, I don't really mind. So currently I've got them in 1, 3, 2. And then I do have an extra pin out there in case I want to add another stack on top of this. But for now, I've only designed this to hold 4. Right, now our shields are dry, we can put them in, but oh no, there is a problem because they don't fit. Oh yes they do, we just have to put them in this way round and then rotate them. Perfect. Now, what we're going to do for now is just leave them in there because we want to first calibrate the servos so that they're in the right position. So let's grab our power cable and plug it into the D1 Mini. You can plug it into either of these 2, it doesn't matter, they both share a power connection. But you can see with those lights there, we're getting power. We can tap it and we see that vibration sensor blinking. The vibration sensor is very sensitive and you do have to calibrate it a little. So just grab your flat screwdriver and you want to just tap it. If it's blinking very fast, you need to slow it down. The adjustment on this is very sensitive, so like a tiny little turn is enough to throw it off. So we're going to do a tiny little turn. Right, I think there it's perfect. We want that LED to stay on for a second or 2 so that the Pico has time to read it to know that we've definitely dropped a pill. Right, my D1 Mini is actually connected to Home Assistant through ESP Home. So I'm going to jump over to my ESP Home tab and just click my button to dispense pills. And what you want to do is make sure that it's in the 0 position. The way I do it is I tell it to dispense pills and then I tap it, just telling it that a pill has been dispensed so that it goes through all of them. So now I know that all of these are in position 0. And position 0 is where the pill gets dropped. So now we can put these shields into position. That's one. Now that all the shields are in, we can run a quick test to make sure that they're all spinning properly. Again, I'll just be tapping the bottom, telling it that pills have dropped. Perfect. And now, I forgot the little cap. It's the same as version 5. This is the one thing that hasn't changed. Just goes in there. And now we can add our pills. Okay, and now we'll just give a little test. And there we go. Perfectly dispensed pills. It needs a little bit of adjustment, but it's there. So if you'd like your own pill dispenser, the STLs are available for purchase on my website along with the rice cleaner. You can print your own rice cleaner. If you'd like to support me in other ways, I have links in the descriptions. It would be greatly appreciated because I'm running out of money. Thank you, and I'll see you next time.